Welcome to RHCSA.GURU. In this lab, we'll explore Logical Volume Management, or LVM. It's a flexible storage management system that lets you combine multiple disks into a single logical volume. So let's get started. Virtual hard disks are already added to the lab setup. In this exercise, we'll create partitions, turn them into physical volumes, group them into a volume group, and then create logical volumes using LVM. Finally, we'll mount those logical volumes to the system. To view the available disks on your system, run fdisk-l. Use it with more to scroll through the output page by page for easier reading. First, open Terminal in VS Code. You'll notice a 5 GB disk named /dev/nvme1n1. We'll use the fdisk tool to create a partition on this disk. So let's start with fdisk/dev/nvme1n1 command to open the partitioning tool for the specified disk. Press N to create a new partition. Then hit Enter, and type P to choose a primary partition. For the first sector, just press Enter to accept the default value, which is usually 2048. That's the standard starting point, so no need to change it. Next, for the last sector or partition size, simply press Enter. It will automatically use the remaining space on the disk. Type P to display the partition details. You should see /dev/nvme1n1p1 listed with the type Linux. Then type L to view the list of partition types and find the hex code for LVM, which is 80. Type T to change the partition type. Then enter 80 for LVM and press Enter. Afterward, type P to confirm, and you should see Linux LVM listed. Once confirmed, type W to write the changes. Now that the partition table is set up, the next step is to create a physical volume. Before creating the physical volume, make sure the LVM2 package is installed on the machine. You can install by running the command yum install LVM2. Next, create the physical volume using the pv-create command. To verify the physical volume, use the pv-display command. This will show you details about the physical volume. Now let's create a volume group. In this example, we'll name it RHCSA.GURU. Create using vg-create RHCSA.GURU /dev/nvme1n1p1 command. To confirm the volume group has been created, use the vg-display command. This will display details about the volume group. Next, create a logical volume with the lv-create command. We'll name it RHCSA.GURU and allocate 5,100 megabytes. To verify the logical volume has been created, use the lv-display command. This will show the details of your new logical volume. Now, format the logical volume and assign a file system to it using the mkfs.xfs command. Next, create a new directory, RHCSA volume, using mkdir command, where we'll mount the logical volume. Now, mount the logical volume to the newly created directory, using the command mount/dev/rhcsalv/rhcsalv/rhcsa volume. Finally, check if the disk is successfully mounted using the df-h command. This will display the disk usage and confirm the new LVM partition is mounted. Next, we'll learn how to extend an existing disk. Follow the upcoming steps to see how it's done. To see the available disks on your machine, use the fdisk.l command. You should notice the me2n1 disk, which is 5 GB of space. Now let's create a partition on this disk using the fdisk command. To create a new partition, type N, then press Enter. Next, type P to create a primary partition. Keep the default settings for the remaining parameters and proceed to create the partition by pressing Enter. Next, type P to confirm that the partition/dev/me2n1p1 is created, and note that its type is Linux. To change it to LVM, modify the type, then use W to write the changes to the disk. Now run the pv-display command to check which group is associated with each disk. You'll see that /dev/me1n1p1 is associated with the volume group, RHCSA.GURU. Now, extend the RHCSA.GURU volume group to include the new partition using the vg-extend command. This adds the new partition to the volume group. Next, let's extend the logical volume. Use the lv-extend command with the L option, followed by the size you want to add, like +5120 for 5 GB. Then, specify the logical volume path. This increases the size of the logical volume. Finally, extend the file system to match the new size of the logical volume using the XFS.GURU command. This ensures the file system is resized to use the additional space. To confirm the disk has been extended, use the df/h command. You should see that the size has increased to 10 GB. Congratulations! You've completed the exercise. Now mark the lab as complete.